Imagine a slab of pale, fine-grained limestone, split perfectly down the middle by a quarryman's hammer. They are pressed into the rock like a divine stamp, is a single, exquisitely detailed feather. It's a ghost from a lost world, a relic preserved for 150 million years. This isn't a hypothetical scene. It's the real discovery made in 1861 in the Solnhofen quarries of Germany. This solitary feather was a tantalizing clue, a prelude to one of the most important fossil discoveries in history. It posed a question that would challenge the very foundations of biology. Who, in a world ruled by giant reptiles, possess feathers? The answer would transport us to the late Jurassic period. Forget the Germany we know today. Picture a vast, tropical archipelago shimmering in a shallow, sun-drenched sea. The air is thick, warm, and filled with the buzz of ancient insects and the leathery flap of pterosaur wings. On these low-lying islands, a creature lived that would forever blur the lines between two great animal classes. It was neither fully reptile nor fully bird, but something magical in between, a living, breathing testament to evolution in action. Today, we journey back to that lost world of tropical lagoons to meet this incredible animal. It's a creature that held the key to one of nature's greatest transitions, a feathered pioneer that took to the skies while still clinging to its monstrous heritage. We're going in search of Archaeopteryx. So what did Archaeopteryx look like? If you were to see one, you might be confused. At first glance, it would appear bird-like, roughly the size of a modern raven or magpie, with a wingspan of about half a meter. Its entire body was covered in feathers, not just the fluffy down of a chick, but complex, aerodynamic flight feathers, remarkably similar to those of birds flying today. But a closer look would reveal a creature of two worlds. Instead of a beak, it had a long snout filled with a formidable set of small, sharp, conical teeth, perfect for snapping up lizards and insects. Its wings were not just for flight. Protruding from the elbow of each wing were three fully formed fingers, each tipped with a sharp, curved claw like a tiny raptor's. And most strikingly, where modern bird has a short, fused pygostyle, Archaeopteryx had a long, bony tail made of multiple vertebrae, just like a small dinosaur, with feathers arranged in pairs down its entire length. How did such a creature live? Its home, the Solnhofen archipelago, was not a dense forest primeval. It was a series of semi-arid islands dotted with low-growing conifers and cycads, surrounded by vast, hypersaline lagoons. The water in these lagoons was so salty and low in oxygen at the bottom that almost nothing could survive there. This harsh chemistry was a blessing for science. Any creature that fell into the water was quickly buried in fine carbonate mud, safe from scavengers and decay, leading to its spectacular preservation. In this environment, Archaeopteryx was a skilled opportunist. Its diet likely consisted of small prey, dragonflies with intricate wings, nimble lizards skittering across the rocks, and perhaps the earliest, shrew-like mammals hiding in the undergrowth. Its sharp teeth were for gripping, not chewing, so it would have swallowed its meals whole. But the question that has fascinated scientists for over a century is, could it fly? The debate has been fierce. The feathers of Archaeopteryx tell a clear story. The flight feathers on its wings were asymmetrical, with a shorter, more rigid leading edge, a crucial adaptation for generating lift during an active downstroke. This is a hallmark of powered flight. However, its skeleton tells a more complicated tale. It lacked a deep, keeled sternum, breastbone, the powerful anchor for flight muscles seen in modern birds. This suggests that while it could likely fly, it was no aerial acrobat. Picture this. An Archaeopteryx scrambles up the trunk of a cycad, using the sharp claws on its wings and feet to gain purchase, much like a modern Hoatzin chick. From a high branch, it launches into the air, not soaring effortlessly like an eagle, but with frantic, powerful flaps, carrying it across a short clearing to another tree or in pursuit of a dragonfly. Its flight was likely short-burst and clumsy, a revolutionary new skill it was still mastering. It was a creature caught between the ground and the sky. Its world was full of dangers. In the skies, Pterosaurs like Rhamphorhynchus were its main competitors for airborne insects. On the ground, it had to be wary of small, swift predators like Compsognathus, a turkey-sized theropod dinosaur whose remains have been found in the same limestone deposits. In fact, one Compsognathus fossil was found with a lizard in its stomach, proving they hunted the same prey. For Archaeopteryx, every day was a struggle for survival, a balancing act between its reptilian past and its avian future. The fossils themselves are storytellers. The world-famous Berlin specimen, arguably the most beautiful fossil ever discovered, shows the animal splayed out in a state of repose, its wings and feathered tail fanned out in breathtaking detail. We can see not just the skeleton, but the ghostly imprints of the feathers that carried it through the Jurassic era. As the late Dr. Angela Milner, a paleontologist at London's Natural History Museum, once remarked, Archaeopteryx is a Rosetta Stone for evolution. It translates the language of dinosaurs into the language of birds, providing undeniable proof of the connection between them. The story of Archaeopteryx began with that single feather in 1861, but it was the discovery of the first skeleton, the London specimen, later that year that truly ignited the scientific world. Purchased by the famed anatomist Sir Richard Owen, it arrived just 2 years after Charles Darwin published On the Origin of Species. For Darwin supporters, it was a perfect transitional fossil, a creature that beautifully illustrated evolution from one group to another. For a century, Archaeopteryx was seen primarily as the first bird. But our perception shifted dramatically in the 1970s thanks to the work of Yale paleontologist John Ostrom. While studying the raptor-like dinosaur Deinonychus, Ostrom noted dozens of skeletal similarities between it and Archaeopteryx. He argued powerfully that birds weren't just related to dinosaurs. They were dinosaurs, a specialized branch of theropods that had survived the Great Extinction. This reframed Archaeopteryx not just as an ancient bird, but as a small, feathered dinosaur on the cusp of becoming one. Today, cutting-edge technology is revealing secrets the fossils have held for 150 million years. High-resolution CT scanning allows scientists to digitally reconstruct the brain and inner ear of Archaeopteryx without ever touching the delicate fossil. These reconstructions show that its brain was more developed than that of non-avian dinosaurs of a similar size, with enlarged regions for vision and coordination, essential for flight. Its inner ear structure suggests a sense of hearing and balance comparable to modern birds. Even more incredibly, scientists can now determine the color of its feathers. Using powerful scanning electron microscopes, researchers have identified preserved melanosomes, pigment-containing organelles, within the fossilized feathers. A 2011 study published in Nature Communications analyzed the melanosomes from the original 1861 feather and concluded that it was likely black and possibly iridescent. So, we can now imagine Archaeopteryx not as a drab-brown creature, but with sleek, raven-black plumage that may have shimmered in the Jurassic sun. Despite everything we've learned, Archaeopteryx still guards many of its secrets. The most pressing question remains the precise nature of its flight. Was it capable of a running takeoff from the ground? Or was it restricted to launching from heights? How far and how fast could it fly? Was it a daily flyer? Or did it only take to the air to escape danger? Other questions concern its life cycle. How did it nest? Did its young hatch with flight feathers? Or did they develop them as they grew? Did it exhibit parental care, or were the hatchlings left to fend for themselves? These are behaviors that rarely fossilize, and answering them requires finding a fossil so exceptional it seems impossible, perhaps a fossilized nest with eggs or a juvenile specimen. The future of Archaeopteryx research lies in both new technology and old-fashioned fieldwork. While extracting DNA is pure science fiction due to its degradation over millions of years, the analysis of preserved proteins or other biomolecules could offer new insights into its physiology. Advanced synchrotron scanning, which uses incredibly powerful X-rays, can reveal chemical traces left behind by soft tissues, potentially mapping out muscles and organs we never thought we could see. and paleontologists continue to search the Solnhofen region, hoping for new specimens that might finally answer these lingering questions. Each new fossil, no matter how fragmentary, has the potential to rewrite a chapter of this amazing story. So why, after more than 160 years, does this raven-sized creature continue to captivate us? Archaeopteryx is more than just a fossil. It is the embodiment of a great evolutionary leap. In its single skeleton, we see the elegant fusion of dinosaurian brawn and avian grace. It shows us with startling clarity that evolution isn't a simple ladder of progress, but a complex, branching tree with creatures like Archaeopteryx representing the pivotal nodes where new possibilities take flight. We began with a single, black feather, a mysterious artifact from a lost world. Now, we see the creature it belonged to, a sharp-toothed, claw-winged predator, a clumsy pioneer of the sky, a dinosaur that was learning to become a bird. Its discovery was a triumph for science, providing one of the most powerful pieces of evidence for Darwin's theory of evolution. Its influence extends beyond science. Archaeopteryx has appeared in countless books and documentaries, becoming an icon of prehistory. It fundamentally changed our perception of dinosaurs, helping to transform them from slow, dim-witted monsters into the dynamic, bird-like animals we imagine today. It is the ancient ancestor in the epic saga of the dinosaurs, a story whose ending is not extinction, but transformation, as its descendants live on in the 10,000 species of birds that fill our world today. From its toothed jaw to its feathered tail, Archaeopteryx is the ultimate transitional fossil, a snapshot of evolution in progress. It teaches us that even the mightiest lineages can change, adapt, and give rise to something entirely new and unexpected. The next time you hear the song of a robin or see a pigeon take flight from a city square, take a moment to remember their ancient, toothy ancestor. Marvel at the incredible 150 million year journey that began in a shimmering Jurassic lagoon. It continues today in your own backyard. The ghost of the dinosaur lives on. Share this story if you were inspired by the tale of this feathered pioneer, and never stop looking at the world with a sense of wonder.